Today I want to give an example that brings together all the different elements that we've been looking at in statistics, brings together basically brings together the two-way ANOVA, follow-up tests, and the ANCOVA, and does it kind of all in one big experiment. And so at first glance, this seems like it's going to be really complicated, but in reality, it's just taking the steps and putting them all together. So if you think about it in terms of a step-by-step process, where we look at several different variables and analyze them all in one experiment, um, we'll look at each element individually, and then that'll allow us to understand and to know how to do this kind of all at the same time, if you will. So I'm going to start by going over, after my dog's done whining. The example I'm going to use is a student project, project from experimental psych, as a way to kind of look at these different variables and analyzing them all at the same time. So I'll just kind of go through this abstract really quick as a way for you to kind of understand what was going on in the experiment, and then I'll kind of go through how we analyze the data. So it says this article analyzes whether a religious symbol affects the perception of short and long-term mating strategies among heterosexual participants. Basically, what we did, or I'm sorry, what the student did was they looked at how does a religious symbol affect the way people perceive someone's mating strategies. And the mating strategies were short-term and long-term. And the name kind of implies what you think. A long-term mating strategy is a mating strategy more centered around marriage and children. Short-term mating strategy is more centered around one-night stands and several sexual partners. So students at Fresno Pacific University, females and males, were randomly given one of four pictures: a male with or without a cross, and a female with or without a cross necklace. Participants were then given a questionnaire to rate the model's characteristics of parenting effort, which was the long-term strategy, and mating effort, which is the short-term strategy. These were ranked from 0 to 100 based on the presence or absence of these dependent variables. A two-way factorial ANOVA, which is what we're going to be going over, was used to test whether the presence of the cross and the gender of the participant had an effect on the perception of mating strategy. So there is our primary hypothesis. The two independent variables are the presence of the cross, so whether or not that cross has an effect on the perception of mating strategy, as well as the gender of the participants. So that calls for a two-way factorial ANOVA. And then, additionally, the religiosity of each participant was analyzed as a covariate to determine if it influenced the results. And so there was a religiosity scale that was given as a secondary measure, and it measured how religious each of the participants were. And so that religiosity was going to be used as a covariate in this particular experiment. So here's what the pictures look like, or here's an example of some of the pictures. Here's a picture of the person with the cross. You can see the cross there at the bottom. And then here's a picture of the person without the cross. And basically it was just kind of, she just used some photo editing software to get rid of the cross. The necklace is still there, but the cross is no longer there. Same thing occurred with a female participant, with a female photograph as well. And a female with the cross, and then the same female without the cross. Bring that over as well. So you can see the necklace is still there, and she did a nice job of getting rid of that cross. So then the idea is, when you are wearing a cross, does that symbol have an effect on what kind of mating strategies would be perceived as being associated, or really not associated, with that presence of the cross? Okay, so now we can move into JASP. And let's look at this data set. So we have our two independent variables, the presence or absence of the cross. Then we have the gender of the participant. And then I'm actually just going to be looking at mating effort, or the short-term strategy. We're not going to go through both. So mating effort or short-term strategy is going to be my dependent variable. Notice that it's scale. And then, of course, religiosity, that's going to be my covariate. Notice as it's a scale as well. That's always a good indicator to help you know which variables are what. So your nominal variables, at least in this kind of example, will always be your independent variables. And your dependent variables or covariate will always be scale. Okay, so let's go ahead and go to the covariate. So just like we've done before, we're just going to do this all in one big kind of overall study or overall look. So let's start with our dependent variable, and that'll be mating. And this is the mating effort. This is the mating effort or a scale of short-term strategy, meaning how much do these persons perceive the pictures as someone who is engaged in a short-term mating strategy. Okay. Then, of course, the cross. We want to see whether or not the cross. Oh, whoops. Sorry about that. So let's take mating back. Now we'll take the cross. That is one of our fixed factors. And then gender of the participant. And then finally, religiosity. Okay. Now then, the other things that we're going to want is, let's see, the additional options will also want the eta square, which we've got in our descriptive statistic. Well, main thing we need is the eta squared. So let's go ahead and look at our results really quick. So the cross, when we look at that, we notice that the presence of the cross was significant. It was it produced a p-value of 0.003 and an eta square of 0.18. Also, gender was also significant, meaning that the males and females answered differently based on the presence of the cross. So that F value was 19.094, and then a p-value of less than 0.001. Finally, religiosity, which is our covariate. Our F value was 0.56, p-value is 0.45. So religiosity did not have an effect. Religiosity was not related to how people rated the photos. And then there was also no interaction effect between the cross and gender. So that's an F value of 2.20, and then the p-value above 0.05. Okay? So if you look, with the cross in general, both males and females tended to rate or tend to rank the person lower on the mating strategy or short-term strategy scale in comparison to without the cross, which tended to be higher. Okay? If you look at the general averages here, which I think I've got, let's see. I've got that under my descriptives. So if you look at, not that, let's just do the, not by gender, but let's just do it by the cross. You notice that without the cross, overall the mean value of that scale was 4.14. And then the mean value with the cross was 3.07. So what appears to be happening in general is that when persons wore a cross, it tended to decrease their perception as engaged in short-term strategies, which kind of intuitively makes sense. Religiosity tends to be more associated with long-term strategies, or a faithfulness, and those kinds of things. Not doing a one-night stand, and so that symbol was probably having an effect on that particular perception. All right, so let's go ahead and go to the results here and how we write those down. So what we're going to do is we're simply going to put together the different factors or the different facets that we've looked at from other experiments or from other results sections, maybe a better way to say it. So here the covariate religiosity was not significantly related to mating effort. Remember, We saw that earlier. And then we write our F value, P, and eta square. There was a significant effect of the presence of the cross on radians of mating effort. We saw that earlier after controlling for the effect of religiosity. Now, next is the follow-up test. I went ahead and just did the Helmholtz test. And for the most part, anytime you have the way that you decide what type of follow-up to test, you can either do the post hoc or the planned contrast. For the most part, when you have different levels of an independent variable, so when we think back to, for example, the puppy therapy, where you had different people interacting with puppies for a different amount of time, either not interacting or for 15 minutes or for 30 minutes. That tends to be the time when you do the Helmholtz planned contrast, because it compares your control group to any level of the independent variable, or I'm sorry, to both levels at once, really. And then it also compares the two levels of the independent variable to see if that has an effect. Now, in this example, unfortunately, there's only two levels to the independent variable, so it's not as important, but I went ahead and did it here as an example. Basically, when you have different levels of the independent variable, we do the Helmholtz. When the variables, when the variables essentially different sorts of things, but there isn't really a control group, we tend to do post hoc tests. So if you remember the example from your homework about the different superhero costumes, there was a Spider-Man, a Hulk, so on and so forth. In that case, there isn't really a control group. So when there isn't really a control group, we tend to just use post hoc tests and compare everything to everything. And that's kind of basically the rule of thumb that we do. For the test, we'll just specify which one to use, but it's still kind of good to have in your notes in terms of the best way to do it. See, in that sense. Okay, so third part, there was a significant effect of gender on radians of mating effort. Okay, once again, that's what we saw earlier. We have our F values, P values, and eta squared. And then we also want to note whether or not there was an interaction effect. Remember, of course, that there was not. There's no significant interaction. There's no significant interaction effect between the presence of the cross and gender on radians of a mating effort. And then this final part is basically just kind of an overview. So therefore, pictures without a cross were thought to be more likely to score high on radians of mating effort, and overall, females rated all the pictures higher on mating effort in comparison to males. And then finally, individual religiosity did not influence the ratings of mating effort. So for that second part, females rated all the pictures higher on mating efforts in comparison to males. You can either use the descriptives tab to get to those means, or you can just do look at your plot. Okay, so if we go back to ANCOVA, and now let's go to our plot. Now the basic way we do the plot is that the horizontal axis will tend to be our primary hypothesis. Okay, so our primary hypothesis in this case was the presence or absence of cross. And then our secondary is going to be gender. So that tends to be the way that we do it. We always want to display our error bars. And so if you notice, so when I take, if I want to go ahead and take this, go ahead and copy this, I'll place it right here. There we go. Okay, so if you look at here, notice how there's a larger difference in the males than there is with the females, and that's where that gender difference goes. So on average, irregardless, females tended to rank people higher on the mating strategy, on the mating effort, i.e. short-term strategy, than did the males. Okay, the males tended to rank people slightly lower, and that's where that difference really lies. Okay, so that gives an overview of what that quiz is going to look like and how to kind of bring all these things together. Make sure to let me know if you have any questions on anything, and good luck finishing up the semester.